Chapter 7 is about rational functions, and what rational functions are they're functions that are fractions. If you think about the word rational, it has the word ratio in it, and basically a ratio can be written as a fraction. So that's what they call them, and when they write rational functions down, they might put something like f of x is equal to p of x over q of x. And that just means you got a function that's got a numerator and a denominator, okay? That's all that fancy notation means, is that it's a function, and you could look at the top as one function and the bottom as a separate function. When we do these things, we really do kind of separate them in our mind. We look at this as one thing, and this is something else, and we've got to be real careful about the kind of things we do, and remember that you can't cross things out. Like if I have, let me just look at the function we're given in the book, f of x equal x plus 2 over x squared minus x minus 6. You cannot cross those x's out. If you do, a puppy dies. Remember that silly meme, if you do this, a puppy dies. If you do this, a kitten dies. Do not cross the x's out. All the top goes together as one thing, and all the bottom goes together as a separate thing. So, for instance, one of the things they're having me do today is to put this in my calculator. On number 1, they say find f of 0, f of 2. Actually, I'm just going to make a chart because that's going to be easier than writing all that out. Here's x and here's f of x. So they're wanting to know what's the function value for 0, 2, 4, and then they kind of go 5, -1, -3. So I'm just going to make a chart because that's be a quicker way to write it, at least here on the iPad and on your paper probably too. So if I want to put this in my calculator so I could get these values, I could plug them all in by hand and do them, but isn't that what your graphing calculator is wonderful at doing? Okay, so remember that on your graphing calculator, let's reset them in case you got garbage in there from some other time. You hit second plus 7, 1, 2, and that clears out everything. Now what I want to do, if I want to put this in the calculator, I'm going to go to the y equal button that's on the very top row on the left. And I'm going to type this in, but when I type it in, I actually have to type in these parentheses or I'm going to mess it all up. So I have to put parentheses, x plus 2, close the parentheses, and then my fraction bar is a divide sign, and then I'm going to type in the bottom, but it also needs to be in parentheses, so the calculator knows you want the whole top divided by the whole bottom. So be careful when you're entering stuff, or you're not going to get the same values as everybody else. Remember on those subtraction signs, you actually have to hit the subtract button. Don't hit that little negative button at the bottom. How am I going to get to see what these values are? Where do I go in my calculator to look at the table? Yeah, that's second graph. So hit second graph, and we can fill this in really quickly. If you look at the x is 0, what you should be seeing on your calculator is like negative 0.3333, and really that's negative a third, and it's if you want to think of it as a fraction. What do you have on 1? We actually need to go to 2. But you have -1, right? What do you have on 4? 1, okay. And then on 5 you have 0.5, which is a half, so I don't care whether you write it which way. And then don't get rid of this when you're done because we're going to be doing some other things with this table. So -1, it's like -0.25. That's the same thing as negative a fourth. And then at -3, remember to get to the negatives, if you can't see them, you have to get your cursor over onto your x column and then space up. It won't space up on the y column. At -3, you got what? -0.167. Yeah, 0 point. So or do all you guys have those values? If you were to graph it right now, this is your typical kind of, you see something like this. I meant to draw that in red. You see something doing this, and then there's another branch over here, and it's like, that's really weird looking. This is what rational functions look like. They usually have 2 branches, and they're usually opposite of each other on the coordinate grid. It's kind of like if that were scooted over here, this is in quadrant 1, this is quadrant 2. It's almost like I have branches in quadrants 1 and 3. This is kind of a weird one because it's scooted over, but anyway, we'll talk about that another time. Okay, so we can see this is, if I were to try to graph this by hand and I don't pick the right points, I'm probably not going to get this shape, am I? So we're going to need to know some things about graphing these. It's not just going to be, let's make a table and plot a lot of points in. It wouldn't work very well. Look in your table and tell me what is f of 3. What does it say? Anybody? Okay. If it says it's an undefined fraction, your calculator may say error. Some of you may say undefined. Is that what the Inspire says? Okay. The Inspire's right. Your TI-84s tell you error on both of these. Do y'all see that in your chart, that it's saying error? This means that what we have here is really, it's called undefined. It means there is no function value there. Let's see why that happened. We might notice it better if we had actually plugged it in by hand. So let me go. The function was x plus 2 over x squared minus x minus 6. So let me just plug 3 in by hand. That would be an easy one, and it would work the same way for the negative one. If I plug 3 in all these places, I would get 3 plus 2 on top is 5. And on the bottom, I would have 9 minus 3 minus 6. Well, 9 minus 3 is 6, and 6 minus 6 is 0. That's why it's saying undefined. And what you notice, if you go back and you look at your graph, so hit second graph again on your calculator, hit graph on your calculator, look at x equal 3. Isn't that where that function's doing something kind of funky? It's like that, and again, I wish I would remember to use a different color. It's doing that, and then it's coming over here and doing that, and that 3 is sitting right here. What this means is there is no y value at 3. It's because when I plugged it in, I get this undefined fraction, so there's no y value there. What is there is this. We call it an asymptote. I can draw it in, and it's going to help me graph. It's not really part of the graph, but if I draw a vertical line there, it's telling me there's no function value there, but what's going to happen is all those other values are getting really close to that line. If I were to go in and graph like 2.99 or 3.01 or 3.1, if I were to do things like that, I would start seeing that those values are getting really close to that line. Some of them are going up and some of them are going down to the left of the line, but they're never going to hit that line. There's never going to be a y value there. That's called an asymptote. Have you ever heard of those before? They're spelled asymptote. They're pronounced asymptote. The P is silent. And so the fact that I've got an error at 3 and an error at negative 2 tells me the same thing. Something's going on over there at negative 2 also. It's not the same thing. Because if you look at your graph, does it look like on your calculator that there's a problem at negative 2? Do you see any lines like that on negative 2? No, it looks like it's just fine over there. So what's going on with that? Well, there's not a function value there either. Let's say negative 2 is there. Your calculator doesn't show you everything about a graph. You have to have your brain screwed on. It won't tell you everything. There is a missing point there because if I plugged in negative 2, I would also get a 0 on the bottom. And my calculator's telling me that when it tells me error. And so there's not a point there, but there's not an asymptote either. There's a way we could have known that was going to happen, and that's what we're going to learn about in this chapter. And so what we do, if we know there's not a point there, but we can tell it's not an asymptote, we just draw an open, you draw like a circle on it at negative 2, and you just realize there's no y value there. That's called a hole in the graph, a hole. So there are holes and there are asymptotes, and the reason they're happening is because my denominator is 0 at those 2 points. And there's a way to tell which ones are going to turn into holes and which ones are going to turn into asymptotes. There's a way to know that, and that's what this chapter is going to tell us, okay? Number 3 asks us what number should be excluded from the domain. Do y'all remember that domain means the x's you can plug in? What x's are not working for us here? We got 2 of them that we had an error on, 3 and negative 2, okay? So my domain is all the x's I can plug in. I can't put in x is 3 or x is negative 2 because they give me issues. So here's how I could write that. I could say, when I want to say that any x can be plugged into an equation except for a couple of numbers, here's what I usually do. I can write R for all real numbers. That stands for anything I want to, except x equal negative 2, x equal 3. I can write that down, and a lot of books will just say, for instance, instead of writing it that way, there's different ways to write things, and different books use different, kind of conventions. Some books just write x not equal to 3 x not equal to negative 2. They might leave the r out, and they would just understand by the fact that they told you it can't be those two numbers that it must be anything else. So those two notations would mean the same thing. Okay. Now number 4 says plot the graph of f. We're looking at it on our graphing calculator, and that's going to be good enough. But I want us to see what's happening close in, because they say try values such as. So let's make us a chart, and we're going to plug in things like 2.9. Remember I told y'all this a while ago, but we didn't look at any of the values. 3.1, negative 1.9. And negative 2.1. Those are the x's they want us to plug in. I can do that in my calculator. I just don't know that we've done much of that yet. Now, if you're looking at your table of values, it's counting by ones, isn't it? In your calculator, when you look at your table, doesn't it count by ones? Okay. So if I want to change that, what I can do is hit second and window on your calculator if you've got an 83 or 84. Second window. What I'm doing is going to table set. So if you've got an Inspire, you need to find the where you would go to table set. If I hit second window, I can change what the calculator, I can do this. Let me do this. I can change what it's counting by, but there's an even better way to do it. And here's what it is. Your cursor's flashing on your screen, right? Take your cursor and take your down arrow and move it where you see independent. This is INDPNT. And right now there's an auto, and your cursor should be over that, and it should be flashing if you got an 84 because it's what it's set to. Take your right arrow and move it over and highlight ask and then hit enter. So you're going to highlight ask and hit enter. All right, number 5, again, we were just looking at the graph on number 4. We could have plotted the graph, but we just looked at it on our calculator, okay? And we just kind of noticed where the points are. Based on your graph, what two different things could happen when the value makes the denominator equal 0? What two things did we see when the denominator was equal to 0? What two things did we notice on that graph? We had two things happen. What was one of them? Huh? There was a hole at x equal negative 2. We couldn't tell it on the calculator, but there wasn't a value there, so we couldn't plot a value. And number 2, what else happened there? Those of you who are looking across the room doing something. What else happens? Asymptote. There was an asymptote. I think it was at x equal 3.
I have a question.